Hello, greetings to you everyone. My name is Enoch Otim, a final year student in Petroleum Geoscience from University Technology Petronas. Today, I'll be doing a technical review presentation of my seismic data processing course on residual static correction for the May semester of 2023. Okay, my contents will include the introduction, where I will give a background of the topic, and then I'll also have the problem statement, and then also I'll get the main content where I will show the how residual static correction is done, and then we shall look at the way forward, what is going to be happening, where the research will go next in the future, and then we'll also look at the research gap, and then we'll also look at current debates, what are people in the industry doing or thinking right now about residual static correction. And then after that, we shall have conclusion and recommendations, and then I will give some references on the papers that I have used for making this presentation. Okay, next up, I would like to start by saying, okay, what is a static residual correction? So static residual corrections are just time shifts applied to traces in order to compensate for time delays, as the static model is a function of time and space, according to Al-Maktar. Okay, these corrections are applied to seismic data to remove the effects of weathered layers and elevations. A static residual correction is just defined as a subset of the static corrections. Okay, why do we need the static residual correction? Well, the main concern where we need to apply the static residual correction is, number one, to obtain a good structural image of the subsurface. And then we also want to enhance the resolution of the seismic data. If these corrections are not done, as we have seen from the definitions, we shall never get a good interpretation of the subsurface. Okay, next up we can see the effects of static correction. So right here, if you look at the image on the left, we can see that this is a weathered layer. That's why you can see it's kind of undulating or hilly. And then the blue line here, the blue line shows us the datum plane, and then here we have the reflector surface, the common depth point. So if we also look to the image on the right, we can also see the surface elevation variations. This also is another cause for of static correction. Okay, moving up next, we'll be looking at the paper. This paper actually talks about the application of the elevation and residual static correction methods on selected seismic data of the West Lohais area in the south of Iraq. So this is the paper I used for this presentation, the review. So this paper is written by Al-Maktar. Okay, the background of the study will show us right here, as you can see on the map. This is the location of the West Lohais area. It's located on the southeastern part of Iraq. Also, we'll see that the topography of the area is characterized by steep surface in the region to the north and to the northeast. Also, the topography of the north and the southeast areas are more complex than the other parts. We also see several sand dunes in the parts of the region. Lastly, we see that the altitude of these dunes range between 100 to 160 meters above sea level. So as we can see, this paper here shows for us exactly why we need to do static residual correction. And also, if we can look at the topic here, we'll see that it talks about elevation and residual static correction, but my focus will mainly be on the second part of it, which is the residual static correction. Okay, why do we need to do static residual correction? The problem statement here is we know that in case of onshore data, the earth is not flat, as we have seen earlier, it is hilly, and then also there is presence of irregular near surface velocity or weathering, that has caused some problems, and that is exactly why we need to apply the static residual correction. Okay, on this slide here, we shall be looking at the computation and application of the residual static correction. So, for us to apply the static residual correction, there are some steps that we need to follow. Step number one is we use these steps here, the same steps. These steps are also the same steps which are applied in the elevation correction. So we use these steps. Now, after using all these steps, then we the results of the stack. After using this, we get the final stack. Then the results of the stack of the elevations are used as the inputs. Then the data must be gathered in a common midpoint. As we have seen in the previous picture, there is the CMP. It shows for us the common midpoint. And then after that, we need to do normal move out or NMO corrections on the data. So we apply the NMO. After applying the NMO, then muting should be applied since the data were supposed to be stacked. Then after that, then we will using of the filtering and gain. Then here we shall be able to get our final results as it has been followed in this research by Al-Maktar. Okay, moving on. Okay, so after following the procedure for the computation, now here we have the final stack section. On the left, we can see the static residual correction. This is actually before the static residual correction has been applied, and if we look to the right, this is after the application of static residual correction. So the final stack section on the left before residual section, and then the one on the right. If we look at the Zubair, at the mark sections like Zubair and Sadi, we could be able to see the improvements on the seismic data section right here as indicated. Alright, on this slide we're looking at the major advancement in static residual correction. We can see that over the past few years, the development of new methods for estimating residual static corrections are more accurate. And then we also see that the development of new methods for incorporating residual statics into seismic data processing. The development of new software tools for static residual correction. These are some of the major advancements. Okay, and then if we look to the right hand side, we can see that we have also tried to apply linear attenuation. And then on the other image here on the right, we see that here we have not applied the linear attenuation, but on the left we have applied the linear attenuation. So what we can observe from this is that the linear attenuation tried to remove the skippings that we have here, the skipping issues, compared to the one without the linear attenuation applied. Next up, we're looking at the significant gaps in the research. So we'll be looking at the development of a unified framework for residual static correction. This would allow for the compensation of different methods and development of new methods that are more accurate and efficient. We're also expecting the collection of data for testing and validating residual static correction methods. This would allow the assessment of the accuracy and performance of new methods. Bro, what is this? Okay, ideas on where the research might go next. It is likely that the research in residual static correction will continue to focus into some following key areas. We see that the development of new methods that are more accurate and efficient, as I've mentioned before. Some people are already looking into it, but that is where we see the research is going into, and that is what is probably going to be applied in major areas. So we also see that the integration of residual static with other data, this will also help. This is something that we're also seeing that might probably come into the near future, especially with the development of AI and supercomputers. It could help to improve residual static correction. And finally, the development of methods that are more robust to noise and complex geology, especially if you are interpreting in areas of let me say things like carbonate areas. The geology is quite complex, and then you really need better methods or better machines to help in order to be able to interpret the seismic data correctly. Okay, we have reached the conclusion section of our presentation. As we have seen from the whole presentation, processing work on seismic line, as shown from the Al-Maktar's paper. Selected line from the West Lohais area is done. The work is of two types of static corrections are applied with the aim of enhancing the quality of the seismic, the quality of the stack section. The processing includes two stages, one before and one after applying of the static correction, as we have seen in the image before. A residual static correction is computed with elevation static correction. The result is like that of the elevation static correction because the formula is almost the same, but a simple partial enhancement in shallow part of the final stack was noticed, as we have indicated from the markers on the previous slide as well. And then also we have seen that as the research in residual static correction continues, this is now the recommendation section. It is likely that the accuracy and efficiency of residual static corrections will improve as well. This will lead to better seismic quality, which will benefit the oil and gas industries and other industries that rely on the seismic data. Finally, using common reflection surface or stacked, or sometimes called as the CRS stack, will give additional information about the subsurface by the attributes, and then just the static residual correction. Okay, right here is the references to the papers that I used, but mainly the Al-Maktar's paper. Here is a reference to the Al-Maktar's paper. We got it on open source from Google Scholar. And then we have reached to the end of my presentation. Thank you for your attention. Bye.